Students, today also we are doing a lesson actually from forces, because force lessons is really important. Even if you are doing mechanics questions, forces is really important. Mechanics questions, work, energy, power, or directly Newton's laws questions or any other mechanics questions, forces really help. But when you are doing electric field questions, magnetic field questions, viscosity questions, surface tense questions, many more, right? The ability to apply forces is really important. So if you haven't practiced that type of questions, you know what happens actually when you are doing that other lessons, actually you find it really difficult to apply the force parts. Maybe you find the real equation and you get the values of forces, but you cannot apply it properly. It's simply because you don't know how to apply it, and you cannot get the vectors and all that. So these questions will make sure. I have given plenty of questions in the playlist, so go through with the playlist questions and try those questions again. I'm telling you this again, try the questions again and again, repeat it, right? Every month you can repeat till you face the exam. Every month you can do all the questions in the playlist. Just try it, trust my words, and try it. You'll be really good with it. And if you find it difficult certain type of questions, what you have to do is just find similar type of questions and go through it. There are plenty of YouTube videos you can find questions, and plenty of books available. I've done a video on books as well, the question where you can find questions, and simply from your tuition class you have questions for sure, right? I have noticed that many students, even tuition and even from school, you are given lots of questions, but you do only few questions that are given as homework. That's it. You don't try all the questions. So it's a thing actually. Whenever you have a free time to study, you have to finish the tute that are given to you. If you really need an A pass, yeah, you have to do this, right? At least 2-3 times you have to finish the given tute. Otherwise, you are not getting there for an A, right? Remember, if you are really smart, unless you are a really smart students, you won't get there if you don't practice. So practice is the key. So let's try these questions now.
Alright students, moving into our very first question. Let's try this question now. The two objects A and B of mass 5 kg and 20 kg slips along a rough inclined plane. Find the tension in the string that connects the object A and B. The coefficient of friction mu equals 0.2, right? So this tension we need to find. So when doing actually this question, we need to consider these two objects as a single system. So because of that, the internal forces, the tensions will cancel off. So we can easily find by applying F equals ma the acceleration. Then by applying the acceleration, we can find the tension. So that's our plan. So resultant force downwards we have mg sine theta, and the normal reaction we have mg cos theta. We should remember these things. Let's apply mg sine theta values now. 200 sine 60, here it's 60 root 3 over 2, that's 100 root 3. So applying the very same for this 50 into root 3. I hope you know what I am doing. 25 root 3. So basically the downward forces we have is 125 root 3, right? Then the frictional force, that is upwards from this 5 kg and this 20 kg. Same equation, F equals mu r. I hope you remember the equation now. Then mu equals 0.2. Normal reaction mg cos theta for this 220 kg, it's 200 cos 60, that's half, right? So 100 into 0.2, that's 20 Newton. And again applying for this 50, 0.2 into 50 into half. So it's 25 into 0.2, that's 5 Newton. So in the upwards direction we have 25 Newton frictional force, and the downwards we have 125 Newton force. So now what we have to do, we have to simplify this, right? Here now let's apply the values we have found earlier. Downwards we have 125 root 3 and upwards, of course, we have 25 Newton, right? So let's apply F equals ma now. Force 125 root 3 minus 25 equals total mass of the system is 25A. I hope you can see 25 we can cancel off, so it's 5 root 3 minus 1 equals A, acceleration. This is the acceleration actually we have now. So let's apply this value in the equation. So we can easily find tension here, but if we can apply F equals ma for this 5 kilogram. Let's try it now. So this is A and this is B, of course, and apply F equals ma for A. So F downward force we have T, and upwards we have the frictional force, that is, we have found it earlier, it's 5 Newton, right? T minus 5 equals tension, let's write it down again. We have a couple of forces, right? Downwards we have mg sine 30, so 50 into root 3 over 2 plus t, and upwards we have 5 is 5 into a. That's right, acceleration we have found. By simplifying, we are getting 25 root 3 plus t minus 5 equals 5 into acceleration, so 5 into 5 root 3 minus 1. Simplifying furthermore, 25 root 3 plus t minus 5 equals 25 root 3 plus 5, right? We are getting closer to answer. 25 root 3, 25 root 3 cancel off, t goes the other way, so we are getting t equals 10 Newton. That is our answer. Alright students, moving into our second question. Coefficient of friction between A and B is 0.2 and between B and C it's 0.8. Find the minimum force F. Here the force F is C. Prevent the object B from sliding and find the acceleration of A. So basically this goes down with 100 Newton force. So for B to be in equilibrium, we need to apply a force upwards force, that's upwards force F1, that friction between B, C. But remember there's another friction between A and B, so that of course that will be F2. So basically for this equilibrium, this 100 Newton must be equal to F1 plus F2. So we get this friction from BC surface and AB surface, right? So F basically mu r to, we need R, normal reaction force. So our answer comes into action here now. This, when we apply F force in this direction, there will be a reaction force in this direction, that is R. Basically it's F for both, because AB are not moving in horizontal direction, so F it should be equal to R, reaction force. So I'm taking R as capital F, remember that. So let's write the equation now. 100 equals F1 F into 0.8, and F2 it's again F into 0.2. So we are getting it's F equals 100. That's the force we need, right? Other than that, they are asking us to find the acceleration of A. Let's apply F equals ma here for A, right? Downwards we have 200 Newton. Okay, we know 200 Newton. Upwards we have minus F2 into ma, right? So what's F2? We have found it earlier. F2 is this, right? That's F into 0.2. That means 100 into 0.2. What's the value? 20. So 20 equals mass, of course, 20 into A. So 200 minus 20, it's 180, 20A. So we are getting acceleration 9 meters, yes, 9 meters s minus 2. Right, acceleration is this. So this is our answer. Alright students, we are moving into the third question. Coefficient of friction between the plank and the mass capital M is mu. Find the maximum velocity that can be given to mass M so that the system will not topple. Right, actually this question is from equilibrium. Let's say when this mass moves into somewhere here, right? Actually if this mass is in between these two pivoting points, actually there it will not topple. Only when it is over here or somewhere here, only this thing will happen. So let's assume it's somewhere here between this point and B. So I'm going to assume it's somewhere here. So downwards we have mass capital Mg, and the mass of the center of gravity mass actually is in between. So total length of the rod is 5L. So 5L by 2, it's 2.5L. There only we have the center of gravity. So it's 3L. It should be somewhere here. That length to this point, actually that length has to be L by 2, right? So total length 3L minus 2.5, 0.5L. That's L by 2, right? Here, right? So let's assume, right, from this point it's x distance away from this point, right? So now what we have to do is we have to take the equilibrium or the moments from this, let's say 1 to second pivoting point, right? So let's apply the equations now. So I'm gonna apply here mg, I hope you can see it, mg, right, into x should be equal to 1.5 mg mean 3m over 2, I'll take it as that, and into L by 2, right? So we need to find the value of x. X equals, let's see, m and m cancel off here, of course mg. So mg and mg cancel off, and we get x equals 3L over 4 from this pivoting point. Let's take whether our calculations are correct. X, yes, that's correct. 3m over 2, right? 1.5m, L over 2. So x equals 3L over 4. We know that, right? So now this x is 3L over 4. So let's see what is the total distance now it has to travel from A to this point. 3L up to here, it's 3L, and then 3L by 3L plus 3L by 4. The total distance will be 15L by 4. Now let's apply conservation of energy. Right, now applying conservation of energy. Initial velocity, let's say it's v, so it's half mv squared. So this mass should come over here and it should be at rest, it should stop. So it's force into distance. So force, the frictional force is F, that is basically mu capital Mg into D, right? So half mv squared. Right, D is the distance. Of course we know the distance, right? Distance D, it has to be 15L over 4, right? Then yes, m is same, it's capital M here, so m and m cancel off, and 2 goes over there. V squared equals mu g 15L, and 2 and 4 cancel, it will be 2, right? So V equals root 15 mu g over 2. That is our answer, right?
Students, as we all know, practice makes it permanent. So just keep practicing in the correct way, right? Because practice makes it permanent. So if you practice it wrong way, and it'll be permanent, right? So keep practicing in the good way and try lots of questions, make it a skill. You'll good to go.